The return no one expected. More than 50 years ago, humanity did something extraordinary. We left Earth, we crossed the emptiness of space, and we stood on the moon. Then, we stopped. No permanent base, no cities, no return missions for decades. To many people, it felt like the moon was a closed chapter, a victory already won. But today, NASA is going back. Not for flags, not for speeches, but for something far more ambitious. This time, the goal is not just to visit the moon, it is to stay, to build, and to use the moon as a gateway to the rest of the solar system. This new effort is called the Artemis program, and it represents the biggest shift in human spaceflight since Apollo. To understand why NASA is returning now and why this mission is fundamentally different, we must first understand why we left the moon in the first place. Why humanity left the moon after Apollo. The Apollo missions were never designed to last forever. They were born from urgency, from competition, from the Cold War. Apollo was a race, not a plan. In the 1960s, the moon was not about science, it was about prestige. The United States and the Soviet Union were locked in a global rivalry. Reaching the moon first was a statement of technological power. Once that goal was achieved, the urgency disappeared. Apollo had succeeded, and success came with a cost. The price of going to the moon. Each Apollo mission cost billions of dollars in today's terms. The Saturn V rocket was the most powerful machine ever built, and it was used once, then destroyed. There was no infrastructure, no reuse, no long-term economy. The moon was incredibly far and incredibly expensive. Political support faded. As public attention shifted, the Vietnam War intensified, social issues took priority, budgets tightened. Political support for lunar missions slowly vanished. NASA was told to move on, to focus on space stations, Earth orbit, reusable spacecraft. The moon became a symbol of a completed chapter. Technology was not ready. In the Apollo era, computers were weak, materials were limited, life support systems were primitive. Long-term stays on the moon were not realistic. There was no way to live off local resources. Everything had to be brought from Earth, which made sustainability impossible. The moon was forgotten, but not useless. Even as missions stopped, scientists never lost interest. The moon held clues about Earth's early history, about the formation of planets, and about resources that might one day support human life. But without the right technology, the moon had to wait. What changed? Today, everything Apollo lacked now exists. Reusable rockets, advanced robotics, artificial intelligence, precision landing systems, and a new understanding. If humanity wants to go to Mars, the moon is not optional. It is essential. In the next part, we'll explore the real reason NASA is returning now and why the moon has suddenly become valuable again. Why the moon matters more than ever today. For decades, the moon looked empty, a lifeless rock, beautiful to see, but useless to stay. That assumption was wrong, and modern science proved it. The moon is not just a destination. Today, NASA does not see the moon as an end goal. It sees it as a platform, a place to learn how humans survive off Earth for long periods of time before we attempt something far harder, Mars. Water changed everything. The single biggest discovery that changed lunar strategy was water, not liquid oceans, but water ice trapped in permanently shadowed craters near the moon's south pole. These regions never see sunlight. Temperatures stay colder than Antarctica, and ice survives there for billions of years. Why water is everything. Water is not just for drinking. It can be split into oxygen for breathing and hydrogen for fuel. That means the moon could one day produce its own rocket fuel. Launching missions from the moon requires far less energy than launching from Earth. Earth's gravity is strong. The moon's gravity is gentle. This makes the moon a launch pad for deep space missions. The South Pole Advantage. NASA's Artemis missions are targeting the South Pole for a reason. This region offers access to water ice, long periods of sunlight, and stable terrain for bases. Sunlight means power. Ice means life support and fuel. Together, they make sustainability possible. A testbed for Mars. Mars is far away. If something goes wrong, help is months away. The moon is only 3 days from Earth. That makes it the perfect training ground. On the moon, astronauts can test habitat systems, radiation shielding, surface construction, resource extraction. Mistakes can be fixed. Lessons can be learned before lives depend on them on Mars. Technology finally caught up. Apollo astronauts worked with less computing power than a smartphone, manual navigation, minimal automation. Today's missions use autonomous landing systems, AI-assisted navigation, and robotics working before humans arrive. Robots will build first, humans will follow. This changes everything. Science beyond survival. The moon is also a scientific treasure. It preserves records that Earth has erased: meteor impacts, solar activity history, early planetary formation. Studying the moon helps us understand how Earth became habitable and how rare that may be. A strategic reality. There is also a geopolitical truth. The moon is no longer empty. Other space agencies are planning lunar missions. Building a presence is not about ownership, but about leadership, setting rules, sharing access, and preventing conflict. The core reason. NASA is going back to the moon because the moon is no longer pointless. It is practical, strategic, essential. In the next part, we'll explore what makes Artemis fundamentally different from Apollo and why this time NASA is not going alone.
Why Artemis is nothing like Apollo. At first glance, NASA's return to the moon may look familiar. A powerful rocket, astronauts in spacesuits, a journey across space. But beneath the surface, the Artemis program is nothing like the Apollo program. In fact, they were designed for opposite purposes. Apollo was about speed. Apollo had one goal: get to the moon before the Soviet Union. Everything else was secondary. The missions were short. The hardware was disposable. The strategy was simple: land, collect samples, leave. Apollo proved that humans could reach the moon. It was a triumph, but it was not sustainable. Artemis is about permanence. Artemis is not a race, it is a foundation. The goal is not just to land astronauts, but to create a continuous human presence. That requires an entirely different mindset. Building, not visiting. Apollo astronauts lived on the moon for a few days at most. Artemis astronauts are preparing for longer surface stays, repeated missions, construction and maintenance. This is exploration with intention, not a one-time achievement. Reuse changes everything. Apollo relied on hardware that was thrown away. Artemis depends on reuse. Reusable rockets, reusable spacecraft, reusable systems. Lower cost means more missions, more testing, more learning. Exploration becomes routine, and routine is how progress happens. Humans and robots work together. In the Apollo era, humans did everything. Today, robots go first. Robotic landers scout terrain.
Robotic systems map resources. Robotic construction begins before astronauts arrive. Humans are no longer alone. They are supported. A global effort. Apollo was national. Artemis is international. NASA is working with space agencies from allied nations, commercial partners, and private launch providers. The moon is not a symbol of one country's victory. It is a shared frontier. The diversity of the crew. Apollo astronauts came from a narrow background: test pilots, military engineers. Artemis crews will reflect humanity: different genders, different backgrounds, different expertise, science specialists, engineers, explorers. This is intentional because building a presence requires many perspectives. Technology finally makes it possible. Apollo worked with minimal automation, limited navigation, and no long-term life support. Artemis uses autonomous landing systems, precision navigation, and advanced radiation protection. This allows missions that Apollo could never attempt. The core difference. Apollo answered the question, can humans reach the moon? Artemis answers a harder one. Can humans live beyond Earth? That difference defines everything. In the next part, we'll look at the new architecture NASA is building around the moon and how it turns the moon into a permanent stepping stone to Mars. Building a gateway beyond Earth. Going back to the moon is not just about landing. It's about what stays behind after the landing is over. For the first time, NASA is building infrastructure that does not return to Earth. At the center of that plan is something called the Lunar Gateway. What is the Lunar Gateway? The Gateway is a small space station that will orbit the moon, not like the International Space Station circling Earth, but on a unique, stable path around the moon. From there, astronauts can travel down to the lunar surface, return safely to orbit, and prepare for deeper space missions. Think of it as a space harbor, a place to stop, refuel, repair, and plan the next journey. Why not launch everything from Earth? Earth's gravity is a problem. It takes enormous energy to lift anything off the planet. Every kilogram costs fuel. Every mission becomes expensive. By staging missions near the moon, NASA reduces that burden. Supplies can be pre-positioned. Spacecraft can be assembled in orbit. Crews can depart without fighting Earth's gravity again. A training ground for Mars. The Gateway is not the destination. It's the rehearsal. Mars missions will require long-duration space travel, radiation protection, and system reliability far from Earth. The Gateway provides a place to test all of that. Astronauts will experience deep space radiation, communication delays, and limited resupply. These are the exact conditions future Mars crews will face. Building a lunar economy. Around the Gateway, a new ecosystem begins to form. Robotic landers, surface habitats, resource extraction systems, private companies delivering cargo. This is not science fiction. It's already underway. The moon becomes a place where systems are built, tested, and improved over time, not abandoned. International and commercial by design. Unlike Apollo, NASA is not doing this alone. The Gateway is being built with international partners. Each contributes modules, technology, and expertise. Private companies handle transport. NASA sets the standards. This spreads cost, it spreads risk, and it accelerates progress. Why this changes everything. Once infrastructure exists beyond Earth, space exploration stops being episodic. It becomes continuous. Instead of one mission every few years, we get a permanent presence, regular travel, and continuous learning. This is how humanity expands, not with flags and footprints, but with systems that stay. The bigger vision. The gateway, the lunar surface, and the moon's resources together form a bridge from Earth to Mars and beyond. Mars is not the next step, the moon is, and the gateway is how we learn to take it safely. In the final part, we'll ask the most important question of all. Why does any of this matter to life on Earth, and what kind of future NASA is really trying to build? Why this time, we're not leaving the moon again. For more than half a century, the moon felt like a memory, a place humanity touched once and then walked away from. This time is different, not because the moon changed, but because we did. The biggest difference? Continuity. Apollo missions ended because there was no system to support what came next, no infrastructure, no reuse, no long-term plan. Today, NASA is not planning a visit, it's building a cycle of regular missions, reusable hardware, and continuous learning. When missions repeat, knowledge compounds and progress accelerates. Economics finally makes sense. In the past, going to the moon was painfully expensive. Every launch required brand new hardware. Today, reusable rockets have changed the math. Costs are lower, launches are more frequent, and private companies share the burden. This makes lunar missions politically sustainable, which matters more than technology. Because exploration only continues when people can afford it. The moon has a job now. Apollo asked, "Can we go?" Artemis asks, "What can we do there?" The moon now has purpose: resource testing, technology validation, crew training, deep space staging. When a place has utility, it doesn't get abandoned. It becomes part of the system. A living presence, not a monument. This time, astronauts won't arrive alone. Robots will already be working. Habitats will be waiting. Power systems will be active. The moon becomes a workplace, not a trophy. Global commitment changes everything. Apollo belonged to one nation. Artemis belongs to many. International partners are invested. Commercial providers are invested. Long-term goals are shared. Walking away now would mean abandoning infrastructure, partnerships, decades of planning. That creates momentum that didn't exist before. Why this matters on Earth? The technologies developed for the moon don't stay in space. They return home, advancing energy systems, robotics, material science, and life support technology. Space exploration has always reshaped life on Earth. This time, it does so continuously. The deeper reason. At its core, this return is not about survival. It's about maturity. Humanity is learning how to exist beyond a single planet without abandoning the one we came from. The moon is the first step towards that balance. Final thought. We left the moon once because we had nowhere else to go. This time, the moon is the beginning, not the end. And for the first time in history, humanity is not asking if it can live beyond Earth, but how.